There's a star right now whose death has already been scheduled to appear in our sky as something that looks like a brand new planet suddenly switched on. It lies 19,000 light-years away in the constellation Scutum. When its core finally surrenders, the light from that moment will cross the galaxy and arrive here, bright enough to rival Venus or Jupiter on a clear night. People thousands of years from now will glance upward and notice a brilliant point that wasn't there the evening before, a sudden unmissable addition to the patterns they've always known. And the part that refuses to settle is this: we still don't know whether that light has already left. The star could have exploded last month, last decade, or it might still be clinging on for another 10,000 years. Either way, the announcement is traveling on a timetable, the universe locked in long before we learned how to point telescopes at it. The sky we're waiting to see has already been decided. We just haven't received the message yet. But while that future light is still making its way toward us, or hasn't even started, we're watching something else entirely. We're seeing the star as it was 19,000 years ago. And what we're seeing is not a calm giant drifting peacefully toward its end. It's already coming apart at the seams. It's shedding mass at one of the highest rates ever measured for any star. Thick, glowing shells of dust wrap around it, lit from within by its own repeated outbursts. The outer layers are so loosely bound that gravity is barely strong enough to hold them in place. Some models suggest it may be on the verge of an even more violent phase before the final collapse, as if the star itself is trying to throw off pieces of its own body in one last attempt to stay intact. The sheer size makes the problem worse. This thing is so enormous that if you placed it where our sun sits, its surface would reach beyond Saturn's orbit. Light would take 9 hours to travel around its circumference. And yet that was cool, red exterior is only the visible skin. The real story is buried so deep inside that we can't watch it happen in real time. After millions of years of steadily fusing hydrogen, then helium, then progressively heavier elements in shrinking shells, the core has reached silicon burning. For a star this heavy, that stage doesn't stretch across days or weeks. It lasts hours, maybe less. The heart of the star is racing through its final fuel at a pace that makes everything that came before feel like a slow, patient prelude. And when that silicon is exhausted and iron begins to appear in any real quantity, the entire structure unravels in seconds. Iron fusion doesn't release energy, it consumes it. The outward pressure that has held gravity back for millions of years simply stops. The core begins to fall inward at a significant fraction of the speed of light. Here's where the story refuses to give a clean answer. We don't know the exact mass sitting in that core. There's a narrow window, a cosmic coin flip we still can't measure from this distance. Below a certain threshold, the infalling material rebounds in a colossal shockwave, and the star explodes as a supernova. Above it, the core keeps collapsing straight through the neutron star stage and becomes a black hole with almost no visible blast at all. The star would simply vanish from the sky over the course of seconds or minutes. Stephenson 218 sits squarely in that dangerous middle zone where both endings remain possible. So when the light finally reaches us thousands of years from now, future observers still won't know in advance whether they'll witness months of a brilliant new beacon slowly fading across the constellations, or whether they'll simply notice one night that a familiar faint star in Scutum has disappeared without ceremony. The brightness that might rival Venus and the possibility that it might never appear at all are both still on the table. And yet even that uncertainty doesn't capture the deeper strangeness. Because if the star does explode, and many stars this size do, the first few seconds after the rebound create conditions nothing else in the universe replicates so violently. temperatures and pressures spike so hard that atomic nuclei are slammed together into combinations heavier than iron. Gold, platinum, silver, uranium. Elements that steady stellar burning cannot produce. These newly forged atoms are hurled outward into the galaxy at enormous speeds. Without repeated events like this across billions of years, the raw materials for rocky planets and the metals we pull from the ground would be far rarer than they are. A meaningful fraction of the gold humanity has ever mined almost certainly began its existence inside the collapsing core of a star. Not unlike this one, forged in its final moments and then mixed into the gas that eventually formed the sun, the Earth, and eventually us. So the bright point that will one day appear in that future night sky isn't only announcing a death, it's delivering the next chapter of the periodic table to whatever eyes happen to be watching. After the visible light fades, weeks or months later, something extreme remains. If the core didn't collapse all the way into a black hole, what's left will likely be a neutron star, an object the size of a city, but containing more mass than the sun, spinning hundreds of times per second with magnetic fields strong enough to distort atoms from light years away. If the core was slightly heavier, a black hole takes its place instead. Either way, a glowing bubble of gas and dust will expand outward from the site for thousands of years, possibly compressing nearby clouds until entirely new stars are born from the debris of this one. One of the giant members of the Stephenson 2 cluster will simply be gone. The others will keep shining, perhaps a little changed by the absence. From our position, none of this carries any danger. 19,000 light years is far enough that no burst of radiation or particles will reach us in any threatening quantity. The event will register on Earth as nothing more than a temporary, beautiful addition to the night sky, a reminder that the universe is still actively building and dismantling itself on scales we can just barely perceive. But that safety is also the part that lingers. If this single star, already unstable, already wrapped in its own ejected material, already deep into its final interior stages, is out there right now with its fate effectively decided, even though we can't yet see the outcome, then how many others like it are scattered through the Milky Way at this exact moment? How many red supergiants have cores that have already entered their silicon-burning sprint, or have already crossed into iron, and are, right now, in the process of choosing whether they will light up some future sky or simply vanish? We can't point to them. Their deaths may already be en route in the form of light that left centuries or millennia ago, or their explosions may still be waiting to begin. Either way, the night sky we see tonight is a composite of events whose causes and consequences are separated by distances that make any single now feel incomplete. The same process that will one day announce itself in Scutum has been repeating across the galaxy for billions of years. Each time, it takes the heaviest elements forged in the heart of a dying giant and flings them outward so that new stars, new planets, and eventually new observers can form from what was left behind. We are, in a very real sense, the aftermath of previous versions of this exact story. And one of the largest remaining chapters is already written. We just haven't received the light from its conclusion yet. When it arrives, the sky will change in a way that can't be undone. A new point of light will hang there for a while, as if the constellation had always been waiting for that moment. Whether it arrives as a prolonged spectacle or a quiet disappearance, the meaning underneath stays the same. Something enormous finished what it started, and in doing so, it made more of the universe possible than it found when it began. The next time you look up at the stars on a clear night, Remember that some of the light reaching you left its source before humans existed. And some of the light that will leave its source tonight won't arrive until long after we're gone. The story doesn't wait for us to be ready to watch it. It just keeps unfolding, one delayed message at a time.